Oh, good. The audio wasn't working this morning. It says find the amplitude, the period, and the graph. So my A is -3. What's the negative on the front telling you? It's going to flip this upside down. Okay, but does that impact your amplitude? No, the amplitude is the absolute value of -3, which means my amplitude is 3. The B is 2 pi. The period is 2 pi over 2 pi. So it's 1. So the coordinate points are easy, right? It would be 0. It'd be 1 times a fourth, which is a fourth. 1 times a half, 1 times 3/4. And the last one is the period, which is 1.
Wait, 0, 1/4.
It'd be 1/4 times 1 half, right? 1, yeah. So those are them. So it's 0, it's 1/4, it's 1/2, 3/4, and 1. And then it's sine. So after we plot our amplitude, we would normally start at 0, go up to 3, and then come back down, down, and up again. But because this is negative, I'm going to flip it upside down. So I'm going to start at 0, but instead of going up, I'm going to go down, up, down. You said it's fun? Yeah, good.
It's fun. It's I like graphing.
Questions on that one?
Graphing little lines and squiggles. It's great.
So we don't have to go the other way?
You don't. Mm-mm. All right, then we're going to skip to 4, so at least we practice with a phase shift. 4 and cosine. 4 is -2 cosine of x plus pi over 2. The A is negative again this time, so it's upside down. The amplitude is 2. The B is 1, so the period is 2 pi. There's a phase shift this time. If I set this equal to 0, it's negative pi over 2. So I'd have 0, I'd have pi over 2 times a half, or times a fourth, sorry, which is pi over 2, and then 2 pi times a half, and then 2 pi times 3/4. So these are normal quadrant angles. Then to each of those, I'm going to subtract pi over 2. I get negative pi over 2. 0, this would be 2 pi over 2. So pi over 2, this would be minus 2 pi over 2, which is pi. And this would be 4 pi over 2, so 3 pi over 2.
Wait, the last one? I mean,
You know you stopped talking, right? You kept looking? All right, I'm going to plot the points. Negative pi over 2. Hang on just a second. Let me write them out. Now we do the amplitude. And then it's cosine. So normally I start at the amplitude. I go down, down, up, up. But it's a negative. So I'm going to start at the negative amplitude. Up, up, down, down. All right, so 4, 6 is the last of the 4 functions. We're going to learn how to do tangent, cotangent, secant, and cosecant, okay? Like I said before, the good thing about secant and cosecant is literally just 2 steps further than sine and cosine. So you already know how to do most of that. Tangent and cotangent are completely different, but it is, again, a step-by-step process that if you repeat the same steps over and over again, you'll understand. The graph of tangent is the first thing that's very different, okay? 1, tangent is undefined on our unit circle. So if you think about as you go around your unit circle and you think about the x and y values, that's where the sine and cosine curve comes from. The tangent values are the y over x. And at 2 places on your circle, tangent's undefined, at the top and at the bottom. And undefined comes across in a graph as an asymptote. So these are asymptotes. These lines are values in which if I put y over x at that point, it would be undefined, okay? So tangent and cotangent both have asymptotes, so do secant and cosecant. Those are those dashed lines. They will not appear on a graphing utility. You'll just see the curves. You won't see the asymptotes, okay? But those are the first things that you're going to find. So the way we do it is completely different than the other stuff.
So they all have asymptotes?
They all have asymptotes, yep. And on a graph that's got multiple ones, what you'll give me is 4 asymptotes and 3 curves. So everything we do today will be 4 asymptotes, 3 curves. Secant, cosecant, tangent, and cotangent will all be that way. So the big difference, obviously, is the shape of them. They have asymptotes. Another big difference is that the period is pi, and we find it by doing pi over b instead of 2 pi over b. So that's another big difference between like the sine and cosine and the tangent and cotangent.
Instead of 2 pi, it's pi.
Instead of 2 pi over b, it's pi. Yep, because the same thing happens every half circle for tangent. So these are sort of the steps. I'm going to alter them a little bit. Like, don't worry too much about this top thing. Okay, for 1, we usually say find A. Okay, the amplitude is not the same kind of thing, but the A is still important, and I'll show you why in a minute. Find B. The period is pi over B. So we kind of start the same way, but A is not called an amplitude. It's the quarter point. I'll show you in a second. Then we find the asymptotes. And to do that, we set bx minus c, whatever is next to tangent, equal to negative pi over 2 and positive pi over 2. So you don't have to worry about a phase shift with these because the asymptotes would be where that phase shift occurs. If you find the asymptotes, it naturally happens.
Bx minus c.
Yep, equals negative pi over 2 and positive pi over 2. Both of them, yep. And those are going to be the middle 2 asymptotes. And then from the one on the left, you're going to subtract the period. And to the one on the right, you're going to add the period. Now you've got your 4 asymptotes. They will all be x equals because they're all lines. So they're all equations, they're all vertical lines, they're all x equals.
So right is add, left is
Subtract. If you switch it, like if you take this one and you add to it, you end up with whatever you got with this one. You'll have a duplicate line. So you know you were doing something wrong.
What?
If you switch this and take the one on the left and add instead of subtract like you're supposed to, you will get the one you already have. So it will like duplicate. So you'll know you did something wrong. So the smaller one, which will, if you always set it up that way, like if you're visual, this is a good way to do it. Set it up. The left, you're going to subtract because that's going to be the very first one on the left. And then the right, you're going to add, and then that's going to be the last one on the right when you go to graph it. So then you're going to plot those, and then you're going to find the halfway point between them. So I would say that's step 3. And this is your 0 or your x-intercept because those are the same thing. So you're literally going to find the exact point that's halfway between the 2 asymptotes. And then you're going to approximate where 1/4 the way and 3/4 the way in are. So like if I'm looking at the one that's here, I would have found this asymptote. I would have 2 more, one on either side. I would find this halfway point, and that's my x-intercept. And then I would just kind of eyeball, I don't need you to be exact, eyeball 1/4 the way in and 3/4 the way in. Eyeball, yeah, like approximate where halfway between those are. And then you're going to go to negative A here, and you're going to go to positive A there. So at the 1/4 point, you go down A, and at the 3/4 point, you go up A, and then you connect your curve.
So 1/4 is negative A.
Correct.
And
3/4 is positive A. Yep. Brian.
So we're not plugging in to find points.
You don't need to find the exact 1/4 and 3/4 point. It would take you years to do this test. We don't have that time. Okay. And then you don't need to worry about this because we've already done it by subtracting the period and adding the period. It's already done.
Wait, how do you find A?
A is the same like it is with sine and cosine. It's whatever's on the front.
And the midway between the
Is
two
literally
is
halfway
the
between.
x-intercept?
Yep.
Or is the x-intercept? Because there's only one, right?
Well, there'll be 3. There'll be 1 for each curve. You're going to find it.
I
Yep.
don't get the pink thing. You just color the circles. You lost me after.
At 1/4 the way in, you go negative A. At 3/4 the way in, you go positive A.
Okay.
Yeah, it starts down and it goes up. Yep.
Will I ever go
Yeah, if it was negative, it would flip. All right, and that's what cotangent shape is too. All right, tangent of 2x. So what is A? 1. What is B? 2. So the period is, remember, it's pi over B. So it's pi over 2. Now I'm going to take what's next to tangent. There's no parentheses, but that is still part of what's attached to tangent. If this said plus 1 at the end, that is a vertical shift. That is not C. So I don't take that, okay? If it's in parentheses, you take it. If it's not, you literally are taking what's attached to the tangent. So 2x. I set it equal to negative pi over 2, and I set it equal to positive pi over 2.
Wait, so if there's no C, you just add them.
Which is this, that you just do what's there. Yep. So then I'm going to divide both sides by 2 or multiply by a half.
It said, oh, bx minus c. Okay.
Yep.
Sorry.
This is gone and I get x equals negative pi over 4. This is gone and I get x equals positive pi over 4. These are the middle two asymptotes. So if I was going from left to right, those are the middle two, second and third.
Like where 10 is undefined.
Yep. Now I subtract from the one on the left. So from over here, I'm going to do x equals negative pi over 4, and I'm going to subtract pi over 2. And over here, I'm going to take x equals pi over 4, and I'm going to add pi over 2.
That's because of the period, right?
Yep.
Is that where
That's where the other asymptotes are going to be.
so
4.
the subtracting and the adding give you the asymptote?
Yep.
And then that gives you
The other asymptote. So you need 4. 4 asymptotes, 3 curves.
okay.
So now this is going to be 2 pi over 4, and I get x equals negative 3 pi over 4. This is also 2 pi over 4, so I get x equals positive 3 pi over 4. So this is the first asymptote, and that's the last asymptote. And now I draw.
Oh, so you only do that once. Plus. Oh.
So now I'm going to mark where my asymptotes are going to go. Negative 3 pi over 4. Negative pi over 4. Positive pi over 4. Positive 3 pi over 4. And then draw your asymptotes. Okay, now we got to find our exact halfway point. So I need to figure out what this coordinate point is here. If it's easy and you can do it in your head, like halfway between negative pi over 4 and positive pi over 4 is 0, that's easy. You don't need to do the work. If you don't know it, then add the 2 and divide by 2. So I would take negative 3 pi over 4, and I would add it to negative pi over 4, and then I would divide that answer by 2. So negative 4 pi over 4, which is negative pi, divided by 2 is negative pi over 2. So you're finding the exact middle point. That's a 0, or an x-intercept.
So like simplify it. You just can, since they have the same denominator.
Yeah.
Could you just know that between 1 and 3 is 2?
Yeah, that's fine. Yeah, they don't always be that way, but yes. And then I already did the, like pi over 4 plus 3 pi over 4. It would be the same, right? So it would just be positive pi over 2.
Oh, so if one's the same on one.
If they are. They're not always going to mirror each other, but this time they do.
Oh.
Yeah. So then a quarter the way in, and this is where we eyeball. We're just going to approximate what that looks like. About a quarter the way in, and then about 3/4 the way in. So divide your little, what you just divided in half, divide again. And then on your y-axis, you want to mark your A, which this time is just 1. 1/4 the way in, you want to go to negative A, which would be negative 1. At the 3/4, you want to be at positive 1. Negative 1, positive 1, negative 1, positive 1, and then connect your curves.
Oh no. What?
Okay, so on
You
this
just
side
know that they're
of
taking
it,
that shape because it's tan positive?
Correct. If it was negative tangent, I would go up and then down. So that a quarter point would be at positive A, and then 3/4 point would be at negative. And if there was a vertical shift, I would wait all the way till the end, and then I'd shift everything up or down. So find your asymptotes, find your center points, and then shift them. Yeah. Sure. A is what?
2.
2.
It's okay. It's very, very excited. All right, x minus pi over 2 is your b. X minus, well, let me do b, sorry. B is 1, and the period would be pi over 1, so it's pi. Because it's pi over b.
Okay, so just tangent and cotangent
Are pi over b. Everything else is 2 pi over b, yeah. Correct. And then x minus pi over 2 equals negative pi over 2, and x minus pi over 2 equals positive pi over 2. Because it's always that way for tangent. That's where your normal tangent, it's where the parent function is undefined. Yep. Yep.
I don't understand what that is.
What part? As it is. All right, so now I'm going to add pi over 2. And I get negative pi over 2 plus pi over 2, which is 0. And then pi over 2 plus pi over 2, which would be 2 pi over 2, which is pi. Those are your middle two asymptotes. To the one on the left, I'm going to do what?
0 minus pi over 2.
Good. Subtract, not pi over 2, pi, because it's the period.
Oh,
That changes. It's whatever the period is this time. No, you're not. Negative pi over 2 and positive pi over 2, that never changes for tangent. Yes. Yes. And you're doing this phase shift. So technically, if it was just tan of x, then it would be at negative pi over 2 and positive pi over 2, but this is shifted. So you shift it by solving for x. It would just be negative pi over 2 and positive pi over 2. Right. All right, then on this side, we're going to add pi, so I get x equals 2 pi. Correct.
I'm gonna get some chapters confused.
We're doing the test all in one day?
Yep.
oh no.
But how many questions?
There's 18.
How many?
18 questions. Yes. Yes. Yes, you'll make it. People have come before you and still are living after taking that. You can be done. Yes.
I mean, I'm not interesting about it.
All right, now comes the asymptotes. And then the halfway point. So halfway between negative pi and 0 would be what?
Wait, but what?
What's halfway between 0 and negative pi? Negative pi over 2. Good. What's halfway between 0 and pi? Positive pi over 2. Good. Halfway between pi and 2 pi? 3 pi over 2. Then we eyeball the quarter, the 3/4, the quarter, the 3/4, the quarter, the 3/4, and mark A, which this time is 2. Yes.
Since the 0 is an asymptote,
Yeah.
it's not gonna cross over the.
It can't cross it. That's why we do the asymptote and then find the point in the middle. And then a quarter of the way in, we're going to the negative A, 3/4 to the positive A, negative A, positive A, negative A, positive A.
Wait.
Yeah. You guys. When you do this step, notice that you're setting it equal to 0 and pi this time. Step 1, still the same. 1 is amplitude, or A, and then B, period is still pi over B. That's the same.
So it's not pi over 2 and negative pi over 2?
Correct. Cotangent is 0 and pi.
So there's no period? It's just
There is. No, the period's the same. The period's pi over B.
okay.
A is the same, period's the same. But 2, where we normally set it equal to negative pi over 2 and positive pi over 2 for tangent, you set it equal to 0 and pi for cotangent.
Why? Because it's always that?
Because that's where cotangent's undefined on your unit circle, at 0 and at pi. Yep. Hang on 2 seconds. Then we go the point in between, right? And then we go the quarter point and the 3/4 point. So the rest of it's the same. All right, cotangent. So what's A? Which means at the quarter point, I'm going to 1 first, and then at the 3/4 point, I'm going to -1, right? Because it switches. B is
Pi over 2.
pi over 2. So the period is
Pi over pi over 2.
pi over pi over 2. keep, change, flip.
2 pi over pi equal to 2.
Oh, shoot.
So the period is 2. I take what's next to cotangent and I set it equal to 0
0 and pi.
and pi.
So where does the 2 go? You just chose
The 2 is what I'm going to subtract and add.
Just chill for now. I love that.
Divide by pi over 2. 0 divided by anything is 0. Divide by pi over 2. Multiply by 2 over pi. It's a little early to give up. We still have a long way to go.
So those are the first 2.
Those are the middle 2, and then we're going to subtract from the one on the left by period, which is 2. Remember, that's the thing that changes. And then at there's your outer 2 asymptotes.
Wait, where'd you get 2 plus 2 from?
I added the period to the one on the right, and I subtracted it from the one on the left.
How do you know which one?
Because you always subtract it from the one on the left, and you always add it to the one on the right. It's the same as tangent. I don't hate you. It takes a lot worse than this. Because the period is 2.
The 0 is for the negative side, and the pi is for the positive. So you're subtracting it.
Sometimes you just keep talking and I don't understand.
Me?
I got you.
That makes sense in her head. And
Yeah.
I'm just listening and I'm like.
As long as it makes sense in her head, it's okay, right? All right, so then I'm plotting -2, 0, 2, 4. Those are my asymptotes. Halfway between -2 and 0. Halfway between 0 and 2. And halfway between 2 and 4. Some of them are going to be that easy. Probably not all of them, but most of them.
Please make it most of it.
Yeah. Go a quarter, half, quarter, quarter, 3/4, right? And then I plot A, which is 1. This time I start at positive A. I start up, and then I come back down. Start up, come back down, start up, come back down. 0 is an asymptote. Yep. It's the first one that we found. So this, again, this time A is -1. So the shape that should be up, left, down, right flips to be up, right, down, left. So it looks like tangent, but the asymptotes would not be in the same spot because we take x minus pi and set it equal to 0. And pi. B is still 1, so the period is pi. No.
No?
No, we really can't. I'm sorry.
Oh, I feel like we're going like Speed Racer.
So there's my middle 2, right? X equals pi and x equals 2 pi. From the one on the left, I'm subtracting pi. To the one on the right, I'm adding
Oh
pi.
my gosh, I'm writing X instead of pi.
Yep.
When I look over my notes, I'm not gonna understand myself.
I'm very sorry. Don't do it. Don't do it. Don't get distracted again.
Wait,
I don't even know what she's saying. I'm a little lost.
Wait, are we gonna finish the whole
Yeah.
today?
7 more slides.
7 slides.
Oh my goodness.
So we're gonna, oh my god, you're graphing. 7 slides.
That's what I'm saying. I'm going so fast.
1 minute is a slide.
I'm not even absorbing anything I'm writing down.
So there's no negatives.
Oh my gosh, what is happening?
I'm not
What we did. What do you mean? We asked so many questions.
Okay, now A is what? 2. B is 1, so period is pi. Good. Take the x plus pi over 4, set it equal to 0, and pi. Subtract the pi over 4. This would be 4 pi over 4 minus pi over 4, so 3 pi over 4. And those are your middle 2 asymptotes. From the one on the left, we're going to subtract the period which is pi. The one on the right, going to add the period, which is pi. So I have negative x equals negative 5 pi over 4 and 7 pi over 4. Find your halfway point. So if I find the halfway point between negative 5 pi and negative pi over 4, that's negative 6 pi over 4. Divide it by 2 or multiply by half, and I have negative 3 pi over 4. It's literally the halfway point between negative 1 and negative 5, if you think about it that way. The halfway point between negative 1 and 3 would be at 1. And the halfway point between 3 and 7 would be at 5. So those are the zeros or the x-intercepts. Eyeball the quarter and the 3/4. And my amplitude, or my A, is 2. And it's cotangent. So I start at the top and then come back down. Cosecant is based off of sine. So you're going to graph it as though it's sine. You get a curve. You see this? That would be whatever sine is. Everywhere it crosses the x-axis, you draw an asymptote because it's the reciprocal of that, right? So the reciprocal of 0 would be undefined. So everywhere there's an x-intercept on the sine graph, you draw an asymptote. And then everything else bounces in the other direction. So if there is a peak or a max, then a parabola bounces off that point. So you're going to get parabola shapes off of each peak and fall or rise and fall, okay? It does exactly the same thing. Yep. And again, you're going to do 4 asymptotes, 3 curves. So there's 2 steps after sine. Find the asymptotes, draw the curves. That's it. Secant is based on cosine. So you're going to graph cosine all the way through like you normally do. Everywhere there's an x-intercept, you're going to draw an asymptote. And then you're going to draw your parabolas off of those max and mins, okay? When you graph this on a graphing utility, you're not going to see the asymptotes and you're not going to see the original sine or cosine curve. You'll literally just see a bunch of parabolas. So if you're checking it on your calculator, be forewarned, it's going to look very different than your hand-drawn one, okay?
Wait, calculator is just gonna.
It's not going to, correct.
Okay.
So this is obviously if it's more narrow, it's stretched out, that's all this is, okay? Here we go. So if it is y equals cosecant of 2x, what am I graphing first?
Sine.
Good. So I'm going to do y equals sine of 2x. You change it, graph it. Well, I do. I mean, you don't have to. Now, A is 1, so that's my amplitude. B is 2, so the period is back to being 2 pi over. Okay, then it's 0. Pi times a fourth, which would be pi over 4. Pi times a half, which would be pi over 2. Pi times 3/4, 3 pi over 4. And the last one, which is the period, is pi. There is no phase shift. If there was, I would add or subtract it on, depending on if it was positive or negative. Then I go to my graph. I plot my points. I plot my amplitude. Sine starts at 0, goes up to the amplitude, down, down, up. I draw my curve. You could make it solid, whatever you want to do. You could do it in a highlighter. You could do it in a different color. I don't care how you do it. Oh, there's only 2. And how many do I need? 3. So your choice is to extend it in either direction, and I don't care which one, and it doesn't have to be exact. It is just an approximation of the extension. So I can extend it to keep going about the same width. Again, it doesn't have to be perfect. And draw that last asymptote. You don't. Nope. But you need at the end 4 asymptotes and 3 curves.
So we would leave our graph like that.
All right, so if it's y equals secant, what am I going to graph?
She's like cosine. Yeah, I thought you guys meant tangent.
So A is 2.
I know, I'm trying.
B is 2 pi. Period is 2 pi over 2 pi, which is 1. I'm going to go straight to the graph because I already know 1 times a quarter and 1 times, like, we know those, right?
Yep.
Sure. I have a 2.
So 0, 1/4, 1/2, 3/4, 1. Amplitude is 2.
I'm gonna. Did you just know though that cosine is not gonna be like enough?
Yeah, they'll never be enough. But it's different with cosine. So this is going to start at 2, come down, down, up, up. My cosine curve looks like this. There's not enough again, and there never will be. This time there's only 2. The easiest thing for cosine is to just finish both sides out. So just go half a curve and half a curve. And you'll get the other ones.
So the asymptotes is like they're the x-intercept.
Correct. Because if you think about it, the x is 0 there, right? So if I use the reciprocal of it, because that's what this is, the reciprocal, you'd flip it, 0 would be in the bottom now. Now you're dividing by 0 and it's undefined. Does that make sense? No. Cosine, but if you're finding the cosine at 0, right?
Yeah.
And it's, or the whatever the answer is, it's 0, right? Now if it was secant or cosecant, you would flip either of those. Whether you're flipping sine or cosine, you're flipping 0. You're putting 0 in the bottom, and now it's undefined. So everywhere it was 0 is now going to be undefined.
Okay. I don't know why I'm doing it. I just.
Okay, so let's say, for example, this had a +1. I'm going to wait all the way till I get to the point. So I would have graphed the cosine curve. I would have found my asymptotes. I would have then shifted everything up 1. So if this was this case, I would have shifted this up 1. This would have gotten shifted up 1. And this would have gotten shifted up 1. Okay? But you want to do the vertical shift after you find the asymptotes. Otherwise, it's no longer where it's crossing through the x-axis anymore, so it's harder to find. So we could take a deep breath. We made it.
Did we do example 5?
We just like all of them on one side. That's all. So again, for test, you're either going to get sine or cosine. You're going to get tangent or cotangent. You're going to get one of those. And then if you get sine, you're going to get secant, so you do cosine. And if you get cosine, you're going to do cosecant, so you do the sine. So you're going to end up doing everything but one, really, because you won't do cotangent or tangent. Lucas.
How much drafting on like the whole test?
There's 3 of these. Yeah. And they're like 8 points, 8 points, and I think the reciprocal one's like 9 points.